Find slope of a graph. So what we're going to be doing is we're going to be looking at a graph, we're going to be finding slope. There's a really easy way to do this, and there are two kind of exceptions that you should be aware of. Whenever we have 2 points that are going to be side by side, you can see that it's not going to have a slant. This is the one I'm talking about right now. You can see that it doesn't have a slant. It's just a flat line. It's like looking at the ground. Anytime that we have something that has a slope of 0, there's going to be no slope, or we're going to call it 0 slope. And you can always go through the slope formula, take the 2 points, y2 minus y1 over x2 minus x1. You can also count the rise and run on the graph, which is what we're going to do here, because I think that's the easiest way to go about doing it. And it also puts you in a mode to where you have to self-check, is this a positive line or a negative line? Does it coincide with the information that I found? Over on the right side, you're going to see that there is a vertical line. And you're like, whoa, that's really slopey, right? That's like a major slant. It's so slanty that it's vertical. This means that it's going to be undefined. So know that vertical lines are undefined. It's not going to have a slope that we can define because it's straight up and down. You're going to notice this whenever you work the slope formula and you have a denominator of 0 instead of a numerator of 0. Numerator of 0 is no slope. Denominator of 0 is undefined. So here are some examples, and here's how simple this can be. So we know that, and this is how I go about approaching these. I would look at the line first and go, this is a positive line because it's going from left to right and it's going up as we look. We always read lines from left to right and we just evaluate what they're doing when we read it from left to right. So what we can do is create right triangles, and that's going to be the same thing as finding the change in y2 minus y1, and then finding the change in the horizontal movement, or the run, which is going to be x2 minus x1. So this is a way to do it on the graph without taking the coordinates. So check this out. Up 1, 2, now I'm even with the other point. So I went rise of plus 2, so change in y. And then I went over 1, 2, 3, 4. So I went over to the right 4. So that was my change in x. We can simplify this and get a slope of 1/2. So if we were to write an equation for this so far, we can see this crossing through at positive 3. We could say y equals 1/2 x plus 3. Take a look at the next one. Oh geez, vertical line. Well, you can see that, and you can still do the change in y and the change in x. So check this out. This is a vertical line. So it's like, is it positive? Is it negative? So finding the rise, 1, 2, 3, and the run is 0. So 3, 0. We know that whenever we have a denominator of 0, we're going undefined. And you're going to be able to spot this in a graph because it's a vertical line. You can see this is a positive slope. So let's hope the information that we get coincides with that. So I'm going to go up 1, 2, 3. So plus 3, and then right 1, 2, 3, 4, 5, 6. Positive 6. It's going to give you a slope of 1/2. You can see this one's a negative line. So instead of counting up for our rise, we're actually going to be counting down, and that coincides. We're counting down is going to be a negative slope. That makes sense. So look, 1, 2, 3, 4. So down 4 over 1, 2. So we have negative 4 over positive 2 equals negative 2. And if we wanted to keep on, taking this unit rate of the slope that we just found, down 4 over 2, it's the same thing as going down 2 over 1. 1, 2 over 1. And you can see that process is going to keep on repeating itself. We can reverse it, go up 2, left 1. So the opposite of both of those values. You can see how this is going to create all the points along the line.